So we were talking about we are still talking about class definition. How do you define a class? Okay? And in that, like we were talking about data members. So you use data members to store the attributes of a class or define the attributes of a class. You have different names for these data members. So remember these names, these terms. You will come across different terms in different books, in different literature. So some people might call them as properties, some might call them characteristics, some might call them simply data members or the attributes of a class, or some might call them as the state of an object of a class. So all these terms, they are interchangeably used to refer to the same thing. From an implementation point of view, they are nothing, just variables. So what are attributes? You just use variables to store different properties of an object of a class. So they are basically called as data members or properties or something like that. So they can be variables of built-in types like float, double, int, character, string, something like that. Or they can be objects of user-defined type. So you can define a type, create a new class, and an object of that class can serve as an attribute or a property for an object of another class. That can happen. We learn about that. In fact, we call it as a relationship between two classes. We say that these two classes, they have a has a relationship. For example, if you have a car object, so a car object is a very complicated object because it is comprised of other objects. It has an engine object. A car has an engine. So a car, it's an object, but it is composed of other objects. One of those objects is the engine object, another is transmission object. An engine is also a complicated object. It has a lubricating system, a cooling system, an ignition system. It has all these cylinders, etc. Okay? So objects, the real world objects and software objects, they can also be very complicated. They can have other objects as their attributes. So attributes are not just limited to built-in types. They can be of any type, built-in or user-defined. And attributes have two fundamental types in terms of whether they are unique or whether they are common across all the members of a class or across all the objects of a class. So for example, if an attribute is specific to an object of a class, okay, so that attribute is called as a non-static attribute or a non-static property or a non-static data member. So a separate copy of that attribute is maintained for each object of a class. For example, we were talking about students. So every student has a unique name, a unique father's name, a unique address, a unique email address, a unique contact number. So all this information is unique for a particular student. And some information that registration number is unique. Some information that we might want to store for you is that information might be shared. Okay, so we may not need to store unique copies of that information for all of you. So we can only have one copy of that information for all of you, and we can use that copy. For example, the name of this university. So when that name would be reflected on your degree, on your transcript, or in any other communication. Okay, so that name is common for all of you. It's the same for all of you. We do not need to store separate copies of that name for each one of you, the name of this university, and it can change. Okay, similarly, we can have other situations in which we would like to have an attribute that is common for all the other for all the members of that class. For example, if you're working on a computer game or on simulation, say for example a game like Need for Speed. So in that game you have different objects, car objects or truck objects or something like that. They are racing against each other. Okay, so how many objects are there in the race? So that is an attribute that is, maybe you can say it is not a unique attribute for each car. It is an attribute that is shared among all the cars that are running that race. Okay, so that attribute you can have a single copy of that attribute for all the objects, car objects or truck objects running that race. You do not need to maintain separate copies of that attribute for all the objects in that race. Okay, So there are advantages to this approach. One, it is easier to maintain such code. If one of the cars or objects, it goes out of the race, you do not need to modify this property for all the objects in that. That would be a lot of work. You have to keep track of all the objects and then modify all these attributes for all the objects. But if there is one variable which is shared among all these objects of the class, then it is easier. You just modify that variable and all the objects get the updated copy of that information. Okay? So such data members which are common among all the objects of a class, they are called static attributes. They are called static attributes. You only need to have one copy of that attribute for all the objects of a class. Whether we have one object of that class or 1,000 objects of that class, doesn't matter. We only have one copy of that attribute in the RAM. The story is different for non-static attributes. Non-static attributes are unique to each object. We need to have unique or separate copies of that object, that attribute for each object of this class. Okay? So the rest of the thing is like written on this slide. Each object of the class has its own copy of a non-static attribute. It cannot be initialized explicitly in the class body. So a non-static attribute, you always need a set function to initialize it, or the constructor. You initialize it in the constructor of the class. And if you do not initialize it, it has garbage value. A non-static attribute, if you do not initialize it properly, it has garbage value. Whereas a static attribute, it is always initialized to 0. For example, if it is an integer or a double value, it is always initialized to 0. If it is some other type, it is initialized to an appropriate value. Okay? But it is definitely initialized. A static attribute or a static data member of a class, it is initialized to a proper value. Yes, a static attribute can be private or public. Okay? So private and public, they are access specifiers which apply to both static and non-static attributes or functions. Okay? We can have static and non-static member functions as well. Okay? Static does not only apply to attributes, it can also apply to member functions as well. There is a difference between a static member function and a non-static member function. So one important difference is, like a static member function can only access or work with static attributes. It cannot access non-static attributes. Why? Because for non-static attributes to exist, you need to have an object in the RAM. Okay? For a non-static attribute, they are only created or they only exist whenever an object of a class is created, because they are specific to an object. They are unique to an object, and we have separate copies of non-static attributes for each object. So they are only created when we have an object of a class. Static attributes, they always exist. Static attributes, when your program is running and it has a class with some static attribute, that static attribute always exists. Okay? Whether we have no object of that class or 1,000 objects of that class, doesn't matter. That object, that static attribute, it is always there. Okay? It is always there. And its lifetime is like, it is the same as the lifetime of your program. Non-static attributes, they are destroyed as soon as the objects of a class are destroyed. Okay? So they go away. They are RAM is taken back from non-static attributes when objects of a class are destroyed. Okay? G. Yes, size of operator works with objects of a class. Definitely works with objects of a class. And usually it gives you the size of all the non-static data members. वो data members जिनकी separate copy होती है for each object, they do not include the static data members. A static data member is not a part of an object of a class. जब आप size की बात करते हैं, ठीक है, उसकी सिर्फ एक copy होती है और वो class wide copy होती है. It is just one copy for the entire class, for all the objects of a class. ठीक है? No, it is not saved in any object. It is, in fact, it is saved in a separate memory segment, the static memory segment. Okay? It is stored in a separate memory segment, the static memory segment. The non-static attributes, they are never saved in that segment. They are either saved in the stack segment if the object lives on the stack segment or they are stored on the heap memory or free memory if the object lives there. That depends upon how do you create that object. If you use the new operator to create an object, then the object lives on the heap memory and all the non-static attributes live there as well. Okay? And if you create an object just like we did in our last class session, so those objects they live on the stack. Okay? So in that case, then these non-static attributes they live on the stack memory or stack segment. Okay? They live there. Static applies to both data members and member functions. Static applies to both data members and member functions. ठीक है? वाह, member function में क्या तुक बनती है static की? ठीक है? अच्छा, so we said non-static members for their existence they require the existence of an object of a class. अगर class का object है तो non-static members होंगे. अगर class का कोई object नहीं है तो non-static data members नहीं होंगे. Static data members they are different. They always exist. Your program is running, so they exist. They do not need an object to exist there. One, okay? So that means like even without an object of a class, the static data members they exist and you can access them as well. Just by using the class name, if they are public, you can access them. सिर्फ क्लास का नाम इस्तेमाल करके, वेरिएबल आपको नहीं चाहिए, कोई ऑब्जेक्ट नहीं चाहिए, ठीक है? Like you have rectangle R1, you don't need R1 dot something or R1 arrow something to access a static member. You can simply say rectangle dot उसका जो static data member है उसको आप access कर सकते हैं, ठीक है? What is the purpose of a static member function? So maybe in C++ we do not have a lot of utility for static member functions, but again these concepts they are common concepts among different programming languages. So for example Java. In Java, you cannot do procedural programming. Any program that you create, it must be a class. So if you're creating a project, okay, so that project must be declared as a class. Okay? Now in that project you need the main function as well. आपको main function हमेशा चाहिए. If you are creating an application, you need a main function because Windows will search for that main function and start executing from that main function. So you are creating an application in Java. So the main function is always a static function. उसकी जो declaration होती है ना, it is always public static int main or void main, something like that. So it is always a public member function, the main function of your class, and it is always a static member function of your class. Why does it have to be static? It has to be static because even if there is no object of the project that you are creating, you should be able to execute this function. That is why it is always declared as static. ठीक है? उसको execute करने के लिए you do not need an object of this class. So static member function, if you are using a static member function, you can call that static member function without having an object of that class in the memory. You can simply call it using the class name. अगर rectangle class का कोई static member function, you can simply say rectangle dot, ठीक है? जो भी उसका member function है, ठीक है? Function का नाम. So that function will be executed without having a rectangle object in RAM. So one static member function पे then we have some limitations as well. The static member function cannot access non-static data members. Q? Because a static member function can be executed even if there is no object of that class in the memory. तो अगर उसका कोई object नहीं होगा तो फिर non-static data members की copy भी नहीं होगी. तो अगर एक static member function non-static data members को access करता है, then you will run into problems because that non-static data member may not exist in RAM and you are trying to access it. ठीक है? Now from an implementation point of view, implementation the sense के C++ like we learn, अभी हम आगे देखेंगे कि non-static data members की copy होती है for each object. For each object we have a separate copy of non-static data members, but static data members की सिर्फ एक copy होती है for all the objects of that class. ठीक है? तो और member functions जो होते हैं, ये तो data members हो गए, member functions उनकी सिर्फ एक copy होती है for all the functions of for all the objects of a class. ठीक है? Data members की unique copies होती हैं, लेकिन member functions, we have separate copies of we have a single copy of member functions for all the objects of a class. Then the question arises, okay, how does the member function know which object to access and which to not access? ठीक है? So उसमें from implementation point of view there is something, यानी C++ provides or passes the address of the object for which that function has been called. ठीक है? So non-static जो member functions हैं, they receive the address of the object for which it has been called. Static member functions, they do not receive that address. ठीक है? Because they cannot access non-static data members, so they don't need that address. So this is something that like you as programmers don't need to be aware of if you're writing programs, but you need to understand that behind the scenes हो क्या रहा है. How does a member function know which object it is accessing? Like how does it know कि ये जो मैंने यहाँ पे width लिखा है या length लिखा है, ये किस rectangle object की width है या किस rectangle object की length? So that information is passed to that member function using a pointer. We call that pointer has a specific name. It is called this pointer. Self pointer in some languages. In C++ it is called this pointer. This is a keyword. So when you say this arrow, so you can access the non-static data members of the particular object for which this function has been called. Non-static member functions get this pointer. Static member functions do not have this pointer. ठीक है? This is another difference. जी.
तो स्ट्रक्चर तभी रन होगा जब उसके कोई ऑब्जेक्ट क्रिएट हो, तभी कंपाइलर जाके वो स्ट्रक्चर टाइप बोले कि तो उस हिसाब से ऑब्जेक्ट बनाए. लेकिन जब ऑब्जेक्ट क्रिएट नहीं हो रहा तो कंपाइलर स्ट्रक्चर की डेफिनेशन को जाएगा नहीं, तो फिर स्टैटिक मेथड्स कैसे क्रिएट.
Okay, so we have this question, if for example we have a class or structure and we said that, like I said that the utility of a class definition is whenever you're trying to create objects of that class, so the compiler looks at that specification and based upon that specification it creates objects of that class. So if we are not creating objects of that class, the compiler is not looking at the specification, so how do we get to have those static data members? ठीक है? Now frankly behind the scenes हो क्या रहा है, that too I don't know. ठीक है? ये जो वाली कहानी है ये आपको समझाने के लिए, ठीक है, कि ऐसे होता है यूटिलिटी स्पेसिफिकेशन और ऐसे ही होता है. ठीक है? Specification is definitely looked at and then based upon that specification objects create किया जाता है. But static data members या static member functions, they are dealt with सेपरेटली. अब इसको बिल्कुल हार्ड एंड फास्ट हम ये नहीं कह सकते कि जी जब तक हम ऑब्जेक्ट नहीं बनाएंगे तो कंपाइलर जब आप अपने कोड को कंपाइल करते हैं ना, तो वो आपके तमाम कोड को कंपाइल करता है, आपकी क्लास फाइल्स को भी और आपके मेन प्रोग्राम को भी, सबको वो चेक तो करता है ना कि आया ये सिंटैक्स वाइज और ये सब कुछ, इफ एवरीथिंग इज इन ऑर्डर और नॉट. Only then can it compile or create the object code, then the linker creates the executable file. So the compiler has gone through that information and the compiler knows before running your program like what are the static variables or global variables that it needs to create. ठीक है? So that thing is done beforehand. ये तो हम वैसे, this is for your understanding that whenever I am trying to declare an object, so before that object is created, the compiler looks at the specific, but the compiler has already done that. Whenever you are compiling your source code and before you actually run it, the compiler has gone through all your code, and when your program is loaded into the RAM, then the compiler has no role as such. Then your code that has been actually built, ठीक है, the executable file, then that code is running. ठीक है? समझ में आई? ठीक है? So ठीक है, those two, ये वो मे बी आपको ज़रा conflicting लगे, but that was for your understanding. और जब आपका कोड कंपाइल हो जाए, so the real action happens when your code is in memory and it is running. ठीक है? That is when the real action takes place. That is when the code in your main program is being executed. So उस वक्त the compiler already knows कि static क्या था, global क्या था, which non-static data members कौन से थे. So which ones do I need to create now? Which ones do I need to create before this program is before this program is like running and at the time of loading. So that information, those things have been taken care of by the time your code is actually running. जी
एक ऑब्जेक्ट हमने क्रिएट कर लिया, उसके अंदर दो ऑप्शन है, एक फंक्शन ठीक है, दूसरे फंक्शन में कोई एरर है। अगर हम फंक्शन कॉल नहीं करेंगे मेन फंक्शन से तो हमारा कोड रन हो सकता है।
No. When you create your now there are different types of errors. For example, there are syntax errors. Syntax error means you have written the wrong C++ code or statement. ठीक है? So those statements, they'll definitely at the compile stage, when you are compiling your code, so your compiler will find those errors and flag those errors, and you will not go ahead with compilation and then building your code. ठीक है? It's not like कि जब तक उसको कॉल नहीं किया जाएगा तब तक compilation is different. और एक्चुअली जब आप रन बाज एरर्स होते हैं they only appear at run time. For example, divide by 0. So at compile time you cannot know whether there would be a situation where the denominator will go to 0. ठीक है? Most of the time you do not know that. Similarly, there can be other situations where the error can only manifest itself at run time. So those errors will be flagged or dealt with at runtime. You can write code for that as well. At runtime, if there's an error, so those are called exceptions. You can catch those exceptions. This is called exception handling. We do not usually cover because we do not have sufficient time for that. But you can do that. ठीक है? अच्छा. So the question, जब आप उसको कंपाइल करते हैं तो वो सारे कोड को देखता है, तब आपको अलाउ करता है कि आया उसको ऑब्जेक्ट कोड में या फिर लिंकिंग उसकी हो सकती है या नहीं. ऐसा नहीं होता कि आपको एट रन टाइम कंपाइल टाइम एरर्स का पता लगे. ठीक है? Now static data members, they are global attributes of a class. That means we have one attribute which is shared by all the objects of a class. So we do not need unique copies of that attributes for all the members. We only need one copy for all the objects. Okay? And we've talked about examples for that. So it can be, by default it is initialized to some value. Okay? For example, if you're using numeric types, they are initialized to 0. If you are using non-numeric types, they are also initialized to their default values. They are not like, you will not get junk in there. They do not contain garbage values. They are always properly initialized. And you can also explicitly initialize them. You have to initialize them. इनकी जो बकाया nitty gritty है, like we will look at the syntax. It's slightly different using non-static data members and static data members. There is slightly different syntax that you have to use. ठीक है? कुछ की requirement ऐसी है कि maybe it may not make a lot of sense to you, but we have to follow that syntax. So we'll talk about that when we get to the lab of static data, but you should know what static data members are and what static member functions are. Okay? I have not explicitly mentioned static member functions here in this slide, but we have talked about static member functions and you should know what they are. Now let us get back to our example of the rectangle class. So we have the rectangle class. It has these non-static data members width and length and one static data member count. And say we have three objects R1, R2, R3 of the rectangle class. Okay? So the width and length, they are non-static attributes. We'll have separate copies of these for R1, R2 and R3. But the count attribute, it is a static attribute. We'll only have one copy for all the objects. Here we have three objects. So we'll have one copy for these three objects. Even if you increase the number of objects, the static attribute, it will have only one copy. The non-static attributes, their copies will multiply, they will increase. जी.
एक फंक्शन के अंदर सारे सेट फंक्शन है, इसके अंदर हमने एक और वेरिएबल डिक्लेयर कर दिया जी x, हमने एक और वेरिएबल, तो फिर ऑब्जेक्ट का साइज
No, the size of the object has only to do with the attributes of the object. Any local variables that you may declare in any other member function, static or not static, it does not have any bearing or any significance towards the size of the object. The size of the object is determined by the size of the attributes, all the non-static attributes of that object. It has nothing to do with the static attributes. It has nothing to do with any local variables that you may declare or create in any member function. it has nothing to do with the return type of the member function. Okay? So it only deals with, it is only affected by the size and number of attributes. G. Static. Doesn't affect. The size of the object is not affected by that. Okay? The size of the object is not affected by a non-static or static variable that has been declared within a member function. It is not affected by that. But it is not part of that object. A static data member is not part of any particular object. It is for the entire class. Okay? Static data member, static variable inside a member function. It has nothing to do with a particular object. Okay? It has nothing to do with a particular object. Okay? Acha. Next is, so this was all about data members. And now we'll talk about member functions. Now what are member functions used for? So they define the behavior of objects of a class. Member functions specify or define the behavior of the objects of a class. Now you can have two types of, broadly, two types of member functions. Or maybe you can say three types of member functions. One is one set of functions called accessor functions. So those member functions, they are used to read or write the values of private attributes. So you have private attributes, and by convention we say that all attributes must be kept private. So you need to read the values of those attributes, and sometimes you might want to change those attributes. Okay? So you can have accessor functions. So accessor functions can have two types: get functions and set functions. Get functions read the value, set functions write the value of an attribute. Okay? The other function is the functions which provide the implementation for the class. For example, if you are writing or creating a class for dealing with fractions. So fraction has two attributes, numerator and denominator. So one is you want to read what is the numerator, what is the denominator, and you want to change the numerator and denominator. The second thing would be you want to add two fractions, or you want to simplify a given fraction. Now these functions, they provide implementation for the behavior, the actual behavior that you want from a fraction class. Accessor and accessor functions, they are also part of the behavior, but they do not implement the actual behavior of a fraction class that we are looking for. Was there a fraction class के attributes को आपको read और write करते थे? लेकिन fractions को add करना, उनको subtract करना, multiply fractions or simplifying a fraction, that functionality is provided by other functions, not by the get and set functions. So we can have implementers or implementer functions. We can also have helper functions. For example, if you look at the fraction class, example of a fraction class. So we said that if you want to simplify a fraction, you need to divide the numerator and denominator by the highest common factor. That means you need to find the highest common factor of denominator and numerator. But you do not need the highest common factor or the function which finds the highest common factor as part of the interface. You only need to simplify a fraction. So you can have a private member function. You can call it, it will be your helper function. It is a member function, but you can keep it private because you don't want it as part of the interface. It's not required. But you can use it for implementing some other behavior. See? So we want to simplify a fraction. For that we need to find the GCD or HCF in order to divide the numerator and denominator so that we can simplify the function. So you can have a helper function which would be a private member function, but it would help you achieve some other functionality. Okay? So these are the different types of member functions. Member functions are declared inside the class body the same way, and these are basically functions. But when we declare a function inside a class, it becomes a member function of that class. It specifies the behavior of that class. It becomes a method of that class. So we use all these fancy names to call, it's just the same function. The same rules apply for creating this function just like the functions that we use in computer programming. But we do it inside a class definition, so it becomes a method or a behavior or a member function of a class. We can place their definition inside the class body or outside the class body. When you place the definition inside the class body, it is called inline implementation. And when you do it outside, it is, I don't know what is called, okay? But that we learn today. So we will declare a class in a header file. We'll just provide declaration there. And in a separate source file, we will define those method functions. Okay? So that there, the declaration of the function and its implementation, it will be two different files. Okay? So if you do it in the same file, in the same, like within the class body, it is called inline implementation, and you can go for multi-file implementation as well. Member functions of a class can access both the public and private members of that class. Member functions, whether it is public, private, it can access the private and public member function data members of that class. The only restriction is if we have a non-static member function, it can only access non-static data members. It can, in fact, it can access both static and non-static data members. But if we have a static member function, it can only access static data members. It cannot access non-static data members. Okay? So this is the only limitation. A member function can access both private and public data members subject to this restriction. What is the restrictions? If the member function is non-static, it can access both static and non-static data members, whether private or public. But if a member function is a static member function, it can only access non-static data members. Sorry, static data members. It cannot access non-static data members. ठीक है? ये restriction है static member function पे. And you invoke or call these member functions using the dot or arrow member access operator. So one question was कि कौन से member access operators हमने last time उनको study किया था. ठीक है? So we only looked at, there are only two member access operators, the dot and the arrow. You use the dot with an object, the arrow with a pointer to an object. ठीक है? G. Inline is a keyword for creating inline functions. Yes. Acha. No, it does not mean that, but we did not talk about inline functions. Okay? Inline functions was part of your programming part of this course. We did not talk about it. Why? Because one, in modern compilers, like even if you use the inline keyword, okay, it is not necessary that the compiler would follow whatever you ask it to do. Inline का मतलब क्या है? You write a function, and when you call that function is like in a separate area of RAM. So when you call that function from the main program, so your programmer or computer microprocessor, it jumps from the main function to that area of RAM and it executes those instructions, then it returns back. Okay? This is normal. If you want to make a function inline, तो वो क्या करता है? जब भी आप उस function को call करते हैं, वो उस function का code उठा के paste कर देता है. You don't have to jump from one place to the other and from one place to the other. ठीक है? Now you can ask the compiler to make a particular function inline. तो उसका जो code है वो वहाँ पे जहाँ पे भी आप उसको call करते हैं वो paste हो जाएगा. So you don't have to jump. Jumping from one location to another, that is slow. It slows down your execution. You want to minimize that. ठीक है? Or you want to be able to predict it with high accuracy. That is what you want to do. But if you cannot predict it and you have to jump over and over again, so that affects your performance because the microprocessor, it has to empty the cache. नई instructions को वहाँ पे डालेगा. फिर अगर आप फिर jump मारते हैं, फिर it has to empty the cache. फिर नई instructions. That slows down your system's overall performance. So previously, programmers had some say in that, but now modern compilers, they are very good at optimizing your code, so it may ignore your instruction case function को inline बना दें. तो वहाँ पे inline का मतलब ये है कि आप जब when you call a function, you don't need to jump to that location. that function's code will be pasted here and you will execute it sequentially without jumping anywhere. That is what inline meant. Here inline means, this is implementation point of view say, okay, you are writing that code, and where do you write that code? So right now the code is not running, that inline takes place at runtime. This inline is like you are writing that code. So as programmer आप code कहाँ पे लिखते हैं? Class की body के अंदर ही function की implementation दे देते हैं. That is inline implementation. वहाँ पे नहीं किसी separate file में, so that is not inline implementation. ठीक है? So it has, this is just a term, that is a keyword उसके अपने specific हाँ जी. Now class definition, access control, something about the access control. We did use these two access specifiers, private and public. Private means whatever you specify as private, it is only accessible to member functions of that class or to friends of that class. Member functions of that class or friends. You can declare a data member as private or a member function as private. That is up to you. सब चीजों को private declare कर सकते हैं, आपकी मर्जी है. By default, by convention, we keep all the data members as private. This principle is called data hiding or information hiding. And all the member functions, unless they are helper member functions, and they do not need to be part of the interface which we want to show to the outside world. So all those member functions become public related. If there is a helper function, जिसको interface में नहीं होना चाहिए, उस class के साथ उसका ऐसा कोई काम नहीं है, so we can declare that member function as private. By default, if you do not use any access specifier, everything is private. If you do not use any access specifier, everything is private by default. This is opposed to structures. In structures, everything is public by default. Okay? So in order to make something public, you have to explicitly make it public by using the public access specifier. But if you do not use the access specifier, it is private by default. Actually, here we have a third access specifier as well, protected. So we have three levels of access in C++. Private, that is the most restrictive. Nobody from outside the class except for friends can access a data member or member function, which has been declared as private. Public is the most liberal. Anything public is accessible from everywhere. Protected is in between. Protected to है, it is protected data members or protected member functions. They are accessible from within the class and from classes derived from that class. So child classes may be, and बात चीजें होती हैं जो कि family में सबको पता होती हैं, ठीक है? So they are not private, they are shared among a family, ठीक है? So they are protected. उस level को हम कहते हैं protected. So derived classes को protected members तक access होती है, whether they are member functions or they are data members. अच्छा जी. Each access control section is optional. Derived classes are classes which you create through inheritance, which you derive from existing classes. You extend an existing class and create a new one. So the new class is called the derived class. The existing class is the base class or the parent class. You can call the new class as the child class as well, or extended class. There are different terms for that as well. So when we get there, we'll talk about that as well. Okay. So you can have many private, public, protected sections. You can repeat them over and over again. But you should follow some convention. Okay, मैंने private data members या member functions को कहाँ define करना है और public को कहाँ करना है, कैसे करना है. So you should follow some rules. Now look at this example of a class. It is class time use की specification है. We have these public member functions, set for setting the time, increment for incrementing the time, write for printing it, ठीक है? उसके साथ एक keyword है const का. So this is a const member function. We'll talk about const member functions in the coming slide as well. And then we have two constructors. One is the default constructor, जो आखिर में है time और within zero पर जो parentheses हैं उसमें there is no argument. This is called the default constructor. And then we have a time constructor, which is used to initialize all the attributes of the time object, और वहाँ पे हम हर attribute की initial value specify कर रहे हैं. So these are two constructors. One is the default constructor, the other is the overloaded constructor. So we talked about function overloaded or constructor overloading in the last section. And then we have these attributes, hours, minutes, seconds. These are private attributes. So if you look at this class, like graphically, This is how it would look. Now, set, implement, write, and these two constructors, they form the interface of this class. This is visible to the outside world. ठीक है? इसलिए इनको border पे draw किया गया है. And these private attributes, hours, minutes, seconds, these are private. So they are only visible or accessible from within the time class. Outside the time class, they are not visible or accessible. How do you define member functions? We have looked at this code. ठीक है? Right? Last time, like we wrote this code. Something like this. ठीक है, उसमें set function शायद नहीं था, but this is inline implementation. यहाँ पे हम class की definition के अंदर ही function की implementation provide कर रहे हैं, declaration के अंदर. So this is inline implementation. This is how you define a member function of a class. This is one way of doing it. We can do it in a separate file as well. We learn about that in this lecture. ठीक है? In fact, उसका तरीक़ेकार ये है. So this is inline implementation, and this implementation is in a separate file. Okay? This is in a separate file. The syntax is slightly different. Okay? This is a set function. ये भी set function. इसकी return type is void. It does not return any value. This is its name. There is two arguments. Here, this is the set function. The return type is void, and these are its arguments. But here we have something extra added to it. So here we have the name of the class. This set function is a member function of the rectangle class. And this is the scope resolution operator. This operator is called this double column that you see, it is called the scope resolution operator. It basically tells the compiler to which particular class does this function belong, because in that source file where we have this implementation, you can provide implementations for different functions from different classes. But in that case, you need to specify which function belongs to which particular class. For that, we use the scope resolution operator. Okay? So the set function है rectangle class. Return type is void. So here we have this is the class name. This is the name of the member function operator, and this is the scope resolution operator. It's not the scope operator. It's the scope resolution operator. Okay? And then you create objects of the class, okay? And you can use two different types of operators to access the data members of this class. If you have an object of a class, so you can say r1.set. If you have a pointer to an object of the class, so say rp, so then you use the arrow member access operator. And either way, like, you can access this member function. I guess the last topic for this particular lecture is const member functions. Okay? Const member functions. Now, we have talked about const in the context of variables. We declared a const variable. So what is a const variable? And similarly, we also talked about const references, if you remember. So const variable is a variable which does not change its value after it has been declared and initialized. So once you declare and initialize a variable, a const variable, you cannot change its value later in the program. That is what it is. What is a const member function? Okay? Now, just like normal variables, for example, you can have a const integer, you can have a const float, a const double. You can also have a const rectangle object. You can say const rectangle r1. Okay? So rectangle r1 is now a rectangle object, but it is a constant object. What does that mean? If we declare an object to be a constant object, what does that mean? That means we cannot change its state. We cannot change the width and length attributes of R1 if it has been declared as const. Okay? Achha. Now the story doesn't end there. If you declare an object to be a const object, that means its state cannot be changed. Who changes the state of an object?
Set functions.
Member functions of a class. Member functions of a class, be it the constructor function or any other function, set functions, they can change the state of an object. They can change the state of an object. Understand? Now, if you call any member function, it can potentially change the state of that object. Now, the C++ compiler, it wants to be sure that you do not call a member function which can change the state of a const object. ठीक है? उसको ये यकीन दिलानी चाहिए कि आप कोई ऐसा मेंबर फंक्शन कॉल नहीं करेंगे जो उस ऑब्जेक्ट की स्टेट को चेंज कर सके। हाँ, डेटा मेंबर्स चेंज कर सके। ठीक है, तो जब आप कोई कॉन्स्ट ऑब्जेक्ट क्रिएट कर लेते हैं ना, तो C++ आपको कोई भी मेंबर फंक्शन कॉल करने नहीं देता एक्सेप्ट फॉर द कंस्ट्रक्टर्स, वो मजबूरी है। ठीक है, अदर देन दैट it does not allow you to call any member function, whether that member function is changing the state of the object or is not changing the state of the object, does not matter. Get function को भी कॉल नहीं करने देगा। ठीक है, तो फिर आप क्या करेंगे? कंपाइलर घबराया हुआ है, आप उसको यकीन दहानी कराएंगे, तसल्ली देंगे कि जी ये जो मेंबर फंक्शन है ये स्टेट को चेंज नहीं करेगा। हाउ डू यू डू दैट? यू डू इट बाय क्रिएटिंग कॉन्स्ट मेंबर फंक्शंस। You declare, just like here, कहाँ गया? Here. Void write const. You put a const here. That makes write as the const member function. Now this is an explicit guarantee to the compiler कि write जो है वो इस ऑब्जेक्ट की स्टेट को चेंज नहीं करेगा। That means the write function will not have any statement जहाँ पे हम कह रहे होंगे hours is equal to something or minutes is equal to something or seconds is equal to something. It will not allow you to write any such statement. ठीक है, इसके अलावा so this is directly आप इन डेटा मेंबर्स को चेंज नहीं कर सकते। अगर आप होशियारी करेंगे नहीं, डायरेक्टली तो नहीं कर सकते, किसी ऐसे मेंबर फंक्शन को कॉल करते हैं यहाँ से जो कि इनडायरेक्टली चेंज कर रहे हैं। यानी यहाँ से हम सेट राइट फंक्शन से we call the increment function. ठीक है, so C++ compiler will not allow you to call a non-const member function from a const member function either. तो आप increment function को भी नहीं कॉल कर सकते राइट से। समझ में आई? What is the problem? const member functions को समझने के लिए आपने बैकग्राउंड में जाना है। Just like any other variable, integer, float, double, you as programmer or any other person as programmer can create a const object. A const object state cannot be modified. You cannot change the state of a const object. Initialization के बाद, construction के बाद, जो भी उसकी state है, you cannot alter that state. मतलब क्या हुआ इसका? उसके जो data members हैं, you cannot change their values. उसका सीधा साधा मतलब ये है। ठीक है? अच्छा, अगर आपने const object create कर लिया, तो फिर उसकी state नहीं change की जा सकती। State कौन change करता है? Member functions of a class. तो C++ का जो compiler है, it becomes overprotective. It does not allow you to call any member function for a const object. ठीक है, फिर तो वो ऑब्जेक्ट यूजलेस हो गया, क्योंकि ऐसे member functions होंगे जो कि स्टेट को नहीं चेंज कर रहे, आप उनको भी नहीं कॉल कर सकते। ठीक है, तो फिर क्या किया जाए? सोल्यूशन इज कंपाइलर वांट्स एक्सप्लिसिट गारंटीज। आप मुझे लिख के दें कि ये फंक्शन स्टेट को चेंज नहीं करेंगे। So how do you do it? You do it by creating const member functions. So you explicitly specify that this function will not modify the attributes or state of this objects of this class. How do you do it? You do it like this. जैसे कि यहाँ write के साथ किया। So that makes it a const member function. Const member function cannot change the attributes directly. You cannot have any statement saying hours is equal to something or minutes is equal to something or seconds is equal to something. Similarly, you cannot call any other function which would change these attributes. So const member function से आप increment को या set को भी नहीं call कर सकते. You cannot like bypass this restriction. ऐसा भी आप नहीं कर सकते. ठीक है? जी. ठीक है. Now the question is, if we are not creating it, so you always remember you are not going to write software from the point of view, from your own point of view. आपने कोड इस तरह लिखना है कि anybody would be using this code. ठीक है? So you are not going to write any restricted code. ऐसा कोड जो कि उस बंदे को restrict कर दे and that person जो है उसको फिर मजीद यानी उसको use ना कर सके. There can be situation where I would need a constant object. There can be situation where I would need constant objects जिनकी state modify ना की जा सके. So in that particular case, I should be able to use that part of the interface जो कि उस ऑब्जेक्ट की स्टेट को मॉडिफाई नहीं कर रहा. Like I should be able to print its attributes or get its attributes. ठीक है. If you do not create const functions, तो फिर आपका कोड यूजलेस हो जाएगा for that person. वो आपके कोड को फिर इस्तेमाल नहीं करेगा. ठीक है. So आपने सिर्फ अपने पर्सपेक्टिव से नहीं सोचना कि मैं तो नहीं कर रहा तो मुझे इनको कॉन्स्ट डिक्लेयर करने की जरूरत नहीं. अगेन एज अ कन्वेंशन, any function that is not changing the state of the object, you should declare it as a const member function. You should follow it as a convention, as a rule. ठीक है. Nobody is forcing you, nobody can force you, but this should be a convention. This is a good programming practice that you can do it, and then your code would be more useful. So ये const member function का फायदा है. सारी स्टोरी है. Now these are the nitty gritties. How do you define it? So any function, just like any function, first return type, void है, int है, double है, float है, जो भी है. Then the name of the function. Then within parenthesis parameter list followed by the const keyword. उसके बाद ये semicolon है. This is the declaration only. यानी अगर आप declare एक जगह करते हैं और define दूसरी जगह करते हैं. और if you are defining it here, so you can have this. So this is inline definition. So return type, function name, parameter list, const keyword, and then the declaration. This is the inline implementation. And if you are doing the implementation in a separate file, so then you use the scope resolution operator. Return type, name of the class, scope resolution operator, function name, parameter list, and then the const keyword. So what does a const member function? What are its attributes? It does not modify the data members. It's a safe function. It does not modify the state of an object. It is illegal for a const member function to modify a class member directly or indirectly, or call a member function that changes the state of the object. So it cannot call a non-const member function, but we will verify it. Okay? We will verify. We have a lab on these objects, these const and non-const member functions as well. So this is an example. Again, the write function tha, it was const. So if you are implementing it or defining it as in separate files, so this is how you can define it. Okay? And यहाँ पे it is not modifying anything, it is just accessing and printing those values. Now we'll write this code. If you have any questions, you can ask. Otherwise, जब हम code लिख रहे हो तो you can ask then. ठीक है? So let us write some code. अच्छा जी. Now I'll write this code, but maybe it will not appear in this recording. For that I have to change the source. ठीक है? अच्छा, let me make some changes. Gee, somebody said that the lecture that I have posted the link to, it is not complete. ठीक है? So in your interest, I'm recording this part. Duplicate. अच्छा. Oh no. Just a second, I need to duplicate these displays. Okay, so now like we can open, or let me create a new project. So this is going to be a console application again. As usual, these are standard settings. This is say rectangle 2. Acha ji. Fine, this part is easy. Now what is the difference? The difference in this case is that we are going to implement the same class in a multi-file setting. Like we'll have multiple files. One will have a header file. The header file will only contain declarations. What is the declared class का क्या नाम है? उसके data members कौन से हैं? Member functions कौन से हैं? No implementation, just declarations. Then we'll have a source file in which we will basically implement those the member functions of that class. Okay? And finally we'll have this main source file in which we will use that the classes that we create. Okay? So how would we do it? So we need to add a source a header file. So you can go to the file menu, you can say new file. So we want to add a new file to this project. This would be a header file, C++ header file. Okay? Go. Acha, we want this file to be included in the debug and release versions of the active project. We need to specify कि इसको store कहाँ पे करना है. So ये rectangle 2 class की project directory है. We want to save it here. अच्छा, we need to specify name for it. Now header files का जो नाम है, again, for example, you have the C math header file, IO stream header file, you have the C standard IO, C time. So the name of the header file, again, it is indicative of the functions contained or defined or declared in that header file. ठीक है? So यहाँ we'll be चूँकि we'll be creating different types of classes, and they may belong to different categories. So usually the name that I choose for my header file, it is my classes. ठीक है? The classes that I create. You can choose a meaningful name for it. ठीक है? But this is what usually I call it. ठीक है? So I'll specify a name for this header file, my classes. This is important because you should remember this name. You have to include this header file in your main source code and the other source file where you will define those functions. So you specify the name and then you use this name to include that header file. Okay? So let us save it and then finish. So this header file, it's an empty header file right now, but it has been created and it has these preprocessor directives included in it. Anything that signs with the hash keyword, it is a preprocessor directive. You can read it. You can say if not defined. This means if not defined, my classes underscore h underscore included. Hash defined my classes underscore h underscore included. Hash end if. So this is called, this is the header guard code. This code is for, it is called the header guard code. Okay, I may have gotten the name incorrect, but you can check it in your book as well. What is its purpose? Its purpose is to prevent the inclusion of a header file more than once in your project. If you include your header file once, then you should not include it again. That will create a lot of problems for you because it will result in multiple definitions of the same functions. So whenever you include a header file, so all the header files, they usually start with this this code. This is the header guard keyword, the header guard word or header guard. Okay? It prevents this header file to be included more than once in your project. That is its purpose. So it will be automatically generated by this code block in IDE. You do not need to do anything with it. Now in the header file, we'll just declare our class. Okay, our class is basically this rectangle. Okay? So this is our class. Now we have not specified the data members or member functions for this class, but this is our class. This is the simplest class, in fact, that you can create. It does not have any data member. It does have two member functions that you do not see, but the compiler provides you those member functions. One is the default constructor, the other is the default destructor. We have not talked about the destructor function yet. We'll talk about it later, but these two functions, they are automatically provided to every class, the default constructor and the default destructor. Okay? Other than that, this class is empty, but this is the simplest class that you can create. You can create objects of this class. Those objects will be entirely useless. You can't do anything useful with them, but nevertheless, from programming and syntactic point of view, this is the simplest class that you can create. Now let us declare the data members. So its data members are int width and int length. Again, I did not specify any access specifier. By default, they are private. Okay? So they are private by default. Let me add this comment so that you remember. They are private by default. Now I want to create the member functions. Okay? So I have used the public access specifier because I want all these member functions to be public. So this is the default constructor. We want to have a default constructor for our rectangle class. I do not provide the body for it. I just end it with the semicolon because this is just a declaration, just a signature. Then we have this rectangle, the overloaded constructor function. Here we specify the length and width. Okay? This is the overloaded constructor. So this is the default constructor. And this here is the overloaded constructor. Okay? Asha, then we have the area function. So we have the area function. It is int area. You can call it get area or simply area. You can declare it as const member function because it does not modify the state of the object. It just calculates something and returns it. So we can declare it as const member function. Okay? Why? Because it does not change the value of width and length. Then we can have the void set function. Okay? So set function will have two arguments. So length and width. If you want to change the length and width of the rectangle object. Okay? So I guess this is fine. This is enough. We only want to demonstrate multi-file programming. So this is the declaration of your class. Nothing, just names. What is the name of the class? What are the names of the attributes, name and type? What are the constructors that we have? And what are the member functions? Names, return types, arguments, signatures, just signatures. Okay? Now we need to implement it. Define all these things. How do you define? You define it in, and if you see at this Project Explorer window, here you have sources which will include all your source file with extension .c++. These are the files with the extension .c++ and your header files, the files with the extension .h. Now we need to implement these functions. We'll implement these in a separate source file. Okay? So we need to add that source file. So let's go to the file menu, then new, create file, and this would be a C++ source file. So let us create it. We want to save it. You can name it, give it some name. So this is going to have the implementation for the classes that we declared in the my classes header file. So usually you name the header file and the source file which contains the implementation for the functions in that header file. You give them similar names. Okay? You can have different names as well, doesn't matter, but usually that is the convention that we follow. So finish. Now this is empty, completely blank. The first thing that you need to do is you need to include the header file that you just created. So the standard header file that comes with the C++ as part of the standard C++ implementation, you specify those header files like this. So if I have to include IO stream, so this is how I do, hash include IO stream. Okay? But the header files that you have created, you're going to specify them like this within double quotes. So hash include my classes .h. This is the header file that we created. This is how we specify it. This is the standard header file that comes as part of the standard C++ implementation. So this is how you specify that. And then if you are using any of the functions in the standard namespace, you can add this statement here using namespace std. Otherwise, it's not required. Okay? Now we need to implement these member functions. So I'm just copying these here and pasting them here so that I don't make any mistakes in naming these functions. Okay? Now this is the rectangle. This is the constructor, default constructor of the rectangle class. But how would the C++ compiler know that it belongs to the rectangle class? So we have to specify it explicitly. So we have to specify the class name, rectangle, and the scope resolution operator. So this is the default constructor of the rectangle class. This is how we connect it to the rectangle class. This is the name of the class and this is the scope resolution operator. Okay? So you should do this with all these functions because all these functions, they are member functions of the rectangle class. Okay? So area, its full name is rectangle scope resolution operator and then area. It is the member function of the rectangle class. Similarly, set is also the member function of the rectangle class. Okay? One thing. Next, we need to provide implementation. So we need to get rid of that semicolon and create a block. Similarly, here too we need to get rid of this semicolon and create a block. Here too we need to get rid of this, and here too. Okay? Done? Okay. So now you can implement these functions. The default constructor. So we want to give default values to those attributes. Okay? So width is equal to length is equal to 1. So it is say a unit square. If you do not specify any values for this rectangle, so the width and length, they are all equal to 1. It is a unit square. Okay? Basically. These are the default values. And here we can do some validation, but I'll save some time and won't do that validation, leave it for you. I'll ask you to do it in the lab maybe for some other class. So here I'll directly assign these values. Length attribute, the value L goes into the length attribute and the value stored in W goes into the width attribute. Length और width को क्यों नहीं है? Because they are defined inside this function, which is a member function of the rectangle class. So here doing scope resolution would be redundant because here the assumption is that all these variables are accessible to this member function. यहाँ पे scope, the question is why don't we specify like here? You can do it. It won't stop you from doing it, but it's not required. Okay? It's not required. It's redundant. Why? Because you've already done scope resolution for a higher level block, okay, which is the function in this case. So all the way, whatever is accessible to this function, so you don't need to do scope resolution for that again. No, इसके लिए नहीं. नहीं. I don't know of anything like that. ठीक है? But इसके लिए आप कह रहे हैं? No. इसके लिए नहीं है. ठीक है? अच्छा, so this is length is equal, ये हमने कर लिया. The same code would be required in set function. ठीक है? So in set function, we need to do the same thing. What do we need to do in the area function? So all we need to do is return length, multiplied by width. Okay? So this is the entire implementation. Now we want to use it. You use it in your main program. So again you need to include it. Hash include my classes dot h. Okay? Now where does the header guard word come into action? Now if you see, we have hash include IOStream here as well as hash include IOStream here. Okay? And this is in the class myclasses.h. Okay? So when we include myclasses.h, it is for this file. Okay? But if I had done it here within my classes.h header file, if I had hash include IOStream, so यहाँ पे फिर if there were no header guard words, then we would have run into problems. ठीक है? अच्छा, now we want to use these objects. ठीक है? So let us use these objects. So let us create rectangle R1. We will create it using the default constructor rectangle R2 we will create it using the overloaded constructor. ठीक है? Now if you see, like we have two constructors, so here you have this list. One of two is the default, the second one is the overloaded constructor. ठीक है? So you can specify values here, 5, and say 5 is the length and 3 is the width. If you leave it like that, yes, it will be default. It's not required, but ये लिखें ना लिखें तो कोई फर्क नहीं पड़ता. ठीक है? Let's verify. I didn't try it. Yes, nothing happens. The default constructor will be invoked. ठीक है? So whether you write these parentheses or you do not write doesn't make any difference. Asha, now let us call the get area function. ठीक है? So cout area of R1 is equal to, and then R1 dot area. ठीक है? And then end line. Okay, and let's do the same for R2. Area of R2 is equal to R2 dot area. ठीक है? Let's compile and then build and run this code. What does it say? R1 dot area request member or which is of non-class type rectangle. Area const rectangle area const R1 dot area. ये तो मसला नहीं कर रहा. Compile, build and run. Okay, so area of R1 is equal to 1 and area of R2 is equal to 15. ठीक है? Maybe that was the problem. You cannot say this. ठीक है? दोबारा इससे try कर लेते हैं. Request for member area in R1 which is of non-class type rectangle. So if you do it this way, then it is not considered or treated as an object of rectangle class. ठीक है? So you should not be using this syntax. You can use it this way. अच्छा, ये प्रॉब्लम कब सरफेस करता है? ये प्रॉब्लम तब सरफेस जब आप मेंबर फंक्शन को अदरवाइज सिंपल डेक्लेरेशंस पे उसने कुछ नहीं कहा. तो अगेन like you cannot always trust the compiler unless and until बाज़ औक़ात आपको ज़्यादा कोड लिखना पड़ता है in order for a problem to manifest itself clearly. अच्छा जी, अब यहाँ पे इसको let us build and run it again. So this is the output and this is understandable. ठीक है? Now let me make one small change to this code. ठीक है? So I am declaring this object as const. ठीक? And I am declaring this function as non-const. Similarly here as well. So we have two objects, R1 and R2. R2 is a non-const object, R1 is a const object. ठीक है? Now we want to see whether this code works fine or not. So it wouldn't. Why? Because we are calling the area function. The area function is a non-const member function. Although it does not modify the state of the rectangle object, but we have not explicitly said so. So the compiler would treat it as a non-const member function and it will not allow you to call it for the R1 object. R1 object के लिए आपको ये allow नहीं करेगा कि आप इसको call करें. ठीक है? So let us compile this code and the compiler flags const rectangle as this argument discards qualifies. So you may not understand कि इसका क्या मतलब है, but the reason is कि R1 is a const object, ठीक है? And R1 dot area is a non-const member function. ठीक है? If I just comment out this statement, then this code is fine. So you can have a const object, doesn't matter, but it is useless. Like you cannot call any function for this object. You can only call const member functions which have been explicitly declared as const. Acha, ji, let me complete it and then you can ask the question. So let us declare it as const. Here again, const. Acha. Let us do something here. Let me call the set function here. Okay? So I'm indirectly trying to modify the state of the object. So I say 4, 5. Okay? So I'm calling the set function from the area function, which is a const function, and the set function is a non-const function. It is supposed to be a non-const function because it is modifying the state of the object. Now can we do something like that? Okay, so let's see. Let us compile this code. It compiles fine, like you don't see any error. So maybe you can say, जी ठीक है, बात बन गई है. But when you build this code, so build linking में, so it will flag कि नहीं जी. You're trying to modify the state of a const object, ठीक है? Or you're trying to modify or call words शायद ये ना हो. Words कह रहे हैं passing const rectangle as this argument discards qualifiers, ठीक है? So the wording may not make that much sense to you, although it is sensible. Why? Because यहाँ पे आप कह रहे हैं r1.area. r1 is a const object. So r1 का जो address है ना वो एक pointer में जाता है, this pointer में, and that pointer is a const pointer. ठीक है? अब using that const pointer, you are calling a non-const function. That is not allowed. So इसलिए वो आप कह रहे हैं passing const rectangle as this argument discards qualifiers. ठीक है? So we cannot do something like this. Similarly, we can also not do something like this. We cannot say length is equal to 4 or 5 or something like that. This is also not allowed. ठीक है? Direct modification भी allowed नहीं है और indirect modification भी allowed नहीं है. So again, build जब आप करेंगे ना तो तब आपको ये पता चलेगा. So this is also not allowed. G, now questions. Answered. G, any question? पूछ रहा था, मैं पूछ रहा था. हाँ जी. नहीं कर रहे. हाँ. Set function, you can call the set function for R2. For R1 you cannot call it. हाँ. ये कलर. हाँ. I want to create an error in set. अच्छा. For example, ये कर दी. अच्छा. ठीक है. It's not like ये तब तक इसको हाँ. Compiler may not find. मैं इसको simple. Let us just compile it. Nothing to be done. ठीक है. Compiler तो कह रहा है कि कुछ भी नहीं करना. अच्छा. Let us fix it and then make this error. अच्छा. Build and run. अच्छा हो गया. Now जी हाँ मैंने अब h हटा दिया. I just want to compile it. Nothing to be done, up to date. So compiler is not flagging this error. So it is in a separate source file. So linker is taking care of it. ठीक है? But it will not be like ignored before your program is converted into an executable file and it is loaded into RAM. At some stage इसको जो है ना it will be fixed. So do not always trust your compiler when you are doing multi-file programming. You have to build and run your code to actually learn about all the possible things that can go wrong. Any question?